All right, so the last one down here, the probability of A given B. All right, so we know that B is all the numbers greater than 13. So given B, given, I only have these 6 numbers to choose from. So that means my denominator is going to be 6. Then we want the probability of an even number. So out of these, that would just be the 14, the 16, and the 18. So the probability of A given B is going to be 3 out of 6. So again, this is my 6. The given changes your denominator. So I don't have all the values to choose from anymore. I only have the values of B to choose from. And then it's the probability of A that it's an even number given that it was a number greater than 13. All right, so then the probability of B given A, if A is the even numbers from S, then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 to choose from. That's going to be our denominator. And out of those 9, the probability that the numbers are greater than 13, then that would just be the 14, 16, and 18. 14, 16, and 18. So, of course, those probabilities are not equal. Sometimes they'll give us our information in a table instead. So, you'll notice that M is male, F is female, R is that the subject is right-handed, and L is that the subject is left-handed. Now, mutually exclusive things are things that can't occur at the same time. Like, you're either 6 or you're 16. You're either a sophomore or a senior. You're either a male or a female kind of thing. So those are mutually exclusive. So if we wanted to find the probability, first off, I'm going to need to total all these things out. So there are 52 males. There are 48 females. There are 87 right-handed, and there are 13 left-handed. And altogether, that's 100. So probability of male is going to be out of 100. There were 52 males out of that 100. Probability of a female, there are 48 out of the 100. Probability of right-handed, there are 87 out of the 100. Left-handed, there are 13 out of the 100. Probability of male and right-handed, so the only ones that are male and right-handed are these 43 out of the 100. Female and left-handed would be these 4 females that are left-handed. Male or female would have to be 1 if you add the males and the females together. Male or right-handed. So we're going to get all the males, which are 52, but then that didn't count the females that were right-handed because it says male or right-handed. So 52 gets all of the males, and then I need to add this 44 to it to get the other right-handed. Female or left-handed. So females would be 48, and I've already counted the left-handed females, so I just need to add the left-handed males. So I would do 48 plus 9 to get 57. Probability of the complement of a male. So if the male was 0.52, the complement would be 1 minus that, so it would be 0.48. Then the probability of right-handed given it's a male. So given it's a male, remember the given changes my denominator. So given it's a male means my denominator is 52. And out of that, there are 43 that were right-handed. So 43 out of 52. Probability of female given left-handed. So I can say that there are 13 left-handed, and out of those, 4 of them were females. And then probability of left-handed given female. Um, so if I'm given it's a female, that means my denominator is 48. And out of those, the left-handed ones were 4 out of those 48. All right, so we've talked a little bit about mutually exclusive events already. Independent and mutually exclusive aren't the same thing. For independent events, one of the following 3 things has to be true. Not all 3 of them, but any one of those 3 things true means that it's independent. And so basically, when we're talking about independent, we're talking about 2 things that are unaffected by each other. So, like, if I draw a card out of a deck of cards, and then I put that card back in before I draw my second card, then those 2 events are going to be independent. One is not going to affect the other. But if I draw a card and I lay it on the desk, and then I draw a second card, that second probability is going to be altered by the first event. And so that would not be independent. So 2 events are independent if the knowledge that one occurred doesn't affect the chance that the other one occurs. So the outcome of 2 rolls of a fair die are independent. The outcome of the first roll doesn't change the probability for the outcome of the second roll. So as we said, to show 2 things are independent, you just need to show one of those previous conditions. If you don't know that they're independent, then assume they're dependent until you can prove it. We've talked about with replacement and without replacement before. That's what we were just talking about with the cards a second ago. Like if you draw a card from the deck and then you put it back in before you draw the second card, that's with replacement. If you draw a card and you don't put it back in before you draw the second card, that's without replacement. So that makes a difference in the probability. If one card is drawn from a deck and it's shown to be an ace of spades, what's the probability of drawing a second card from the deck and it being a black card if the first card is returned? Well, if the first card is returned with replacement, you still have all 52 cards to choose from and you still have all 26 black ones. But if that first card is not returned, it's without replacement, you only have 51 cards in the deck left to choose from, and only 25 of those are black. So those 2 would not be independent events. The second scenario down here would not be independent because you can see it's changing the probability. A and B are mutually exclusive events if they can't occur at the same time. Like we were saying, you're either a boy or a girl. So that means the probability of A and B would be 0. So if they give me this set of numbers and they give me A and B and C, and they ask me to find the probability of A and B, you can see that 4, 5 is in A and 4, 5 is in B. So that would be 2 out of those 10 numbers. So the probability of A and B wasn't 0, so that means they're not mutually exclusive. All right, probability of A and C, there's no number in A that is also in C, so that probability is going to be 0. So A and C are mutually exclusive. They can't happen at the same time. So we're getting these answers just by using common sense and logic. In the next section, they're going to give us formulas for computing these as well. All right, so they tell me let event G be taking a math class, and that probability is 0.6. Let event H be taking a science class, and that probability is 0.5. Then G and H taking a math class and a science class would be 0.3, and they ask us, are they independent events? So if they're independent events, one of these 3 things has got to be true. I would have to be able to show that. And so if we use these numbers that we had up here and we calculate, then they are independent because we can see one or more of them is true.